Firewall Clustering, Part 1. Now we've arrived at one of the most important aspects of this particular series, and that is clustering our checkpoint firewall solution. In this nugget, we're going to cover how to set up a new mode HA cluster for high availability using the Checkpoint Cluster XL software that's built into the Secure Platform operating system. We're actually going to look at the migration from a single firewall to a cluster through our dashboard, as well as configuring things on our command line options. We will look at our new mode HA cluster setup. We will also do a verification of the cluster, and we will look at failover as well as a few command line options for verifying that everything is set up as it should be. Now, as stated, this is going to be a very important subject to understand how to cluster your checkpoint firewalls, and I really think you're going to enjoy it. So let's discuss clustering. In our previous nugget, we saw how we can deploy a Smart Center server in a management HA situation, and that gave us complete redundancy for our checkpoint security policy. Now we're going to do the same thing with our firewalls, because in a given day you could lose a switch, you could lose memory, you could lose a hard drive, or you could lose a power whip in your data closet for one particular rack. And it's very nice to have a secondary firewall in place in order to immediately transfer the load over to that particular box seamless to your users. And that's the beauty of clustering in today's networks. Clustering has came a long way in the last 15 or 20 years, and in my opinion, it's one of the greatest technology inventions in that time period. There are clusters today for email servers and database and anything that you can think that's really critical to a company, no matter what operating system it's on these days, can be clustered. So what we're going to do, let's go ahead and dive into our dashboard here, and we're going to look at the many ways that we can set up our particular cluster in order to get some redundancy into our company for the Nugget Lab. Alright, so what we see here is on the checkpoint here, on the left hand side we have our checkpoint firewall and our two management servers. So what we're going to do is we're going to go ahead and add a cluster object. So we're going to select new checkpoint cluster. We're going to tilt to use the simple mode. The classic mode gives you just a plain cluster screen, which we'll see in a couple minutes anyway. So we'll go ahead and select OK here. And now we need to give the cluster a name. And the cluster name is going to be whatever we want it to be. In our case, it's going to be Nugget-Cluster. Alright, that looks great. And now we need to give it a cluster IP address. The cluster IP address is a virtual IP, or a VIP as it's more commonly known. And that's a term that you need to become familiar with, and it's going to closely match your CCSE objectives as well. But the VIP is going to represent the internal side, in this case, for the virtual IP that all of our hosts are going to map their default gateways to. And in this case, it's going to be 10.20.1.1 for us. And we have a few options here. It says choose the cluster solution we want to use. We're going to start out by using Checkpoint's Cluster XL on Secure Platform in a high availability mode. We could also do load sharing, and if we're going to get into that as part of the next 2 to 3 nuggets that we cover on clustering. There's just a lot of clustering technology here, and we're going to cover all of it to get you 100% up to speed on what it takes to get a cluster solution rolled out in your organization. So when you get the call from your manager saying, "Hey Joe, I'm quite concerned about our firewall infrastructure, and if we lose something, we need to make sure we have a secondary firewall to take over." And as stated, that's what a cluster is for. So if we hit the drop down here, we have a few options. We have a Cluster XL, which is what we're going to do. We have VRRP for Nokia. We have Nokia IP clustering and other OPSEC. Now the other OPSEC is going to be for some of Checkpoint's vendor partners, such as Resilience and Crossbeam. They each make their own hardware chassis that run a Checkpoint firewall daemon, and they use a little bit different clustering mechanism, but the concepts are the same. Once you learn how to build a cluster on a secure platform setup like we're going to do, 99% of that knowledge is going to transfer. Whether you're running into these other types of hardware vendors, all that knowledge is going to transfer. And the beauty of Nokia is that Checkpoint now owns Nokia. So now Nokia's security appliance line became part of Checkpoint's infrastructure earlier this year in 2009. So you have a one-stop shop for calling for support on a Nokia appliance as well as a Checkpoint secure platform appliance. But off of that tangent for now, let's go ahead and select next and get our actual cluster object defined. So now we need to select add, and we can do new cluster member, or we could add gateway to cluster. So what we're going to do is we're going to try to add our existing one to a gateway cluster, and it's not going to work for us. It's going to give us an error, and I want you to see this error because you're going to see this from time to time and it will pop up. It says the gateway cannot be added to the cluster since it's used in places where cluster members are not allowed. What that basically states is that you are using this object somewhere. You're using it in the install on column, you're using it as part of a NAT object, and you're also using it as part of maybe a policy installation target filter under the policy menu up here. So what you have to do, you have to clear a firewall out of each one of these areas before you can add it to the cluster. Now that's something you have to think about as well as part of your planning if you have the ability and the timing to do this. A lot of times you walk into a situation and you know that firewall's already been running for some time. It's a standalone firewall and there's not a lot you can do about planning ahead for setting up a cluster. But let's take a look at a couple things. We're going to kind of have to stop here for a few minutes and get some things cleaned up, and then we can continue on getting our cluster defined. So we'll hit OK here for now, hit OK here for now, and let it hit that, and we'll hit cancel, and we'll tell it just to do finish for now. It's going to create a certificate operation succeeded. We'll hit OK, and it says for certain configurations you need to edit the gateway cluster properties and select the OS. So we'll hit OK. So we got the cluster object, and now we need to clean up some things right here on our current Nugget firewall that's defined, and where it's defined inside of our security policy here. So let's take a few minutes. We're going to go through all those and clean all those particular items up. So let's take a look at exactly what we're going to have to clean up in order to get this firewall usable in our Nugget cluster. As we know, inside of our node section here, we have a couple options where we had selected a Nugget firewall as well as a Nugget PC and some other types of NATs that we put in place. So if we expand our node section, if we open up our Nugget PC-A, if we select NAT, we can see that we have a current NAT in place over to this particular firewall for this public IP in order to advertise it outbound. So what you need to do is you need to write this information down and or do screenshots or both as you're making these types of changes so you can be 100% successful in recovering all your NATs and things after you get your cluster object defined. So what I'm going to do for now is I'm going to go ahead and unselect this, and as you can see, that was a 172.20.20.22, and under the general properties for this particular object, it ends in a .22. I try to match the two up in my own environment here if possible, but you may not be able to do that. But just use the actual pen and paper as well as a screenshot of the particular object just to make sure you know exactly where it was and what it was doing. So let's go ahead and hit OK on that one. That'll take that one out, and we have under our actual networks here, if we open up our 1020 network, we can see that we had a hide NAT on this particular object as well. So we're going to select that and we're going to remove that. And pretty much the easiest way to find out where everything is used at is to right click on your firewall that you're trying to add and do a where used. And it's going to tell you in the active policy we have it set up on a network object for a host in the NAT firewall objects. We have it set up on a network object right here for the NAT firewall option. We have it set up in the standard policy packages installable targets area. So basically it's going to tell you there the different areas, and then on the active policy it's going to say it's going to do the destination or the install on or destination. it's going to tell you exactly where everything's being used. So you can write down and screenshot these two menus and then go through and clean everything up, and then you would be ready to install it all back into your particular cluster object. And I'm going to take a couple minutes, go through these areas that it lists as far as the install on column over here, and make sure I've removed all the particular NATs that are on like the Nugget management server and all of the things that are pointed toward this particular firewall. So I'm going to go through that, and then I'm going to come back on and we're going to get everything configured for our cluster. So we'll be in good shape here in just a couple minutes. So we went through and cleaned everything up for this particular firewall object. So what we're going to do now is just to verify. Once we have all the different options cleaned up for the install on column, as well as the NATs, as well as the policy installation targets menu right here, we need to be able to come to this object, right click, do a where used, and it should say that the object is not used. So now we can define it as part of our cluster object. So if we open up our Nugget cluster, we go to cluster members and we choose add gateway to cluster. We select this, we hit OK, and it's going to say as part of this, when the Nugget Firewall 1A is added to the cluster, it will be converted to a cluster member and some of its data will be lost. The following data will still remain: SIC, topology, VPN, NAT, except for IP pools. And are you sure you want to continue? So you say yes to that. And it says referred entry does not exist in the certificate authority. So basically what it's saying is that it's trying to revoke the certificate. So we say close to that. And what we're going to do is we're going to have to make sure that we have saved this particular object and that we have the actual certificate information where it needs to be. So what we have to do to correct that error is to open this up, and we'll uncheck VPN for a second. We'll hit OK. And it's going to tell us that it doesn't exist, and that's perfectly fine. We'll click yes again. We'll hit OK, and then we'll save this particular policy. We'll open this up, and let's try to select VPN. And then when we click OK here, it should put it back in. But let's check just general communication. SIC status says it's communicating. Looks good. And let's just see what happens here. We may have to do a little bit more, but let's just see. And it says that, and certificate operation succeeded. Alright, so let's see if we can put it in the cluster object at this point, or if it's going to give us another error. But let's see, add gateway to cluster, this one. Can we add it? Certificate operation succeeded. It's in the cluster. So you see that there's a little caveat there where it threw an error that you typically won't see a lot, but that's how you roll through it and you clean it up. You uncheck VPN and then you recheck VPN, and what that's going to do is it's going to clear out the reference for this particular object in the certificate authority, and then we're going to re-add it to the certificate authority. So good point to remember. Keep that in your toolbox for sure. Alright, so now let's add our new particular cluster member that I created to this particular Nugget cluster at this point. So that other firewall we created is a Nugget FW-2A or 1B is what it's going to be. So let's go do new cluster member, and let me pull this up to verify everything, get the SIC key ready to go, and we'll get this added in, and then we'll continue on with our cluster build from here. Okay, so let's add that particular Nugget cluster object in at this point and get that firewall added to our cluster. So it's going to be Nugget. Let's click right here, make sure we're typing on it. Dash firewall dash 1B. And its IP is going to be 10.20.1.3. Communication. And just like setting up any firewall, we're going to turn this on. There is one additional option I want to show us where it says trust established, so we're in good shape. So let's close that, and we'll hit OK. And now we have both of these members in the particular cluster. So one thing that we need to look at is the option where we need to turn on the clustering. And the way you do that is through the cpconfig menu that we've seen a few times here. Whenever we go in to reset our SIC key via cpconfig, there's also a menu in there to enable clustering on the gateway. So you just hit that option, it'll turn on clustering, and you need to reboot the gateway. And once you reboot that particular firewall, once it comes up again, you'll be able to turn on the checkpoint high availability daemon for the cluster. So we have both of these in here for now, so we're in pretty good shape. We need to do a few more additional things in order to get this cluster ready to go to deploy it. So we're going to go to topology, and under topology you need to select edit topology, and you need to go under get all members topology. So let's go ahead and do that. We have all this defined now. Now let's discuss exactly what we're going to set up here. As stated before, we got to set up a virtual IP to be represented on the cluster for each subnet or pair of interfaces that we want clustered. So as you can see, we have a 172.20.20.3 and a .4 here for our outside network or our internet connection that's being advertised. So we need to set up a virtual IP here in order to make sure we get some redundancy in our network. Should we lose one external interface, we're going to continue on. And that's the point of the cluster. So what we're going to do is I recommend using the actual interface name when you create your actual virtual IP here, or virtual interface. So we'll do edit interface, and this one was ETH0, and its actual IP is going to be 172.20.20.2. And we're using a 24-bit subnet mask. Alright, looks good. And under topology here, we can tell it that it's an external one, and to perform anti-spoofing based on the interface's topology. So select OK there. And now, this needs to be on cluster, and that's what we have now. So you have a few options here, where if you hit the drop down, we have cluster, cluster first sync, cluster second sync, third sync, first sync, second sync, third sync, monitored private, and non-monitored private. Now basically what it is, some people like to run their synchronization traffic between the cluster nodes over an existing cluster interface, and there's some situations where you want to do that, but in most clusters I have seen, you want a dedicated interface for the cluster sync traffic, which is going to be the packets that are going to pass between the two firewalls to make sure that every connection that's in the firewall's connections table is copied over to the secondary firewall. That way, if an outage was to occur, it would immediately be able to fail over and start honoring those connections. And that's essentially what the sync is for. Now, monitored private is pretty much what you set up on a particular firewall if you're not going to be using that interface. And if it's not being used for a particular cluster interface, for example, then you would set it up to, maybe you want a dedicated management interface on each one of your cluster members. You could do that with a monitored private interface. It's not going to apply the checkpoint clustering daemon to that interface. And the non-monitored private is where you would typically mark an interface if it's not being used. Sometimes you'll get a server that maybe it has 12 interfaces in it, and you need to only cluster 6 interfaces. So those remaining 6 interfaces are going to pop up whenever you fetch the topology, but you can use a non-monitored private to make sure they do not affect the clustering mechanism that's inside of your checkpoint security policy. So remember that term, and if you're not going to be clustering every one of those interfaces, mark them as non-monitored private and you're going to be fine. And the monitored private, as stated, you can use that for a dedicated interface on the box, but it's not going to be clustered as well. And the only other thing we're going to use is our first sync interface. So let's look at that now. Now this next one is going to be our first sync, where we're going to send all the synchronization traffic between Nugget Firewall 1A and 1B, just to make sure those connections are synchronized. And then our last one is our internal cluster, VIP. So we're going to define that like we did earlier as 1020.1.1, and this is going to be ETH2. So we'll do ETH2, and the IP address is 10.20.1.1, and let's put its subnet mask in. Okay, looks good. Topology, alright. Anti-spoofing looks good. It's going to be on an internal interface. We hit OK. And as you can see, it goes from inconsistent and it pops over to a normal screen at this point. And that's what we want from our cluster. So we hit OK. And that looks good at this point. And now we can go to Cluster XL and we have a few options here I want to show you. We can do new mode, high availability, which is what we're doing currently. We could do a legacy mode for high availability. Now, legacy mode is basically this. It's kind of a tricky setup, and I'm going to explain to you exactly what it is. Legacy mode is for someone who only has like one set of licenses. What they will essentially do is build two firewalls with the same IP address information, meaning that like we had our 172.20.20.2 on our outside and our 10.20.1.1 on the inside, they would build two firewalls in that same type of setup using that same virtual IP, but the physical IPs between the two nodes would be exactly the same. That way, if you lost one node, it would just continue on the same routing path using the same information. Now, Checkpoint's kind of gotten away from the whole legacy mode setup. They still support it, and it does work, but you're not going to see it in a lot of organizations today. But that's pretty much what legacy mode is all about. And you can pull more information on that if you want to learn more about the legacy mode through the various Cluster XL documentation. But let's go ahead and continue on from here. And this is the important one. We can do up on cluster member recovery. What do you want it to do? Do we want to maintain the current active cluster member, or do we want it to switch to higher priority cluster member? Let's say you build out a couple servers. Maybe one of them has higher memory than the other. Using this particular option, you could always make it recover back to the one that has the higher processing power, and maybe it's the newer box of the two in the cluster. So what I like to set it up to do is to switch to higher priority cluster member. And what we're going to see here is we're going to make our existing firewall, which is our Nugget firewall 1A, our actual primary member, is what we'll see in a few minutes here. And as we can see, it's going to do new mode. We're going to switch it to the higher priority cluster member. We're using our state synchronization because we need to sync our traffic. This load sharing doesn't apply at this point. And the tracking for the statuses of the cluster members, we're going to log that type of traffic toward our firewall log so we can view it in Smart View Tracker. So let's hit OK here. And it says we need to specify the operating system and different things. So let's open that up. And secure platform. And if we do get OS, looks good. Alright, that looks fine, that looks fine, that looks fine. So we can hit OK. Alright, so we didn't get any errors there. So now, what we can do is under Policy, Installation Targets, we can add our cluster object in. And that will take care of the whole situation there. And where this is very important though is make sure that you're using that policy installation target. That way you do not accidentally install the wrong policy on the wrong firewall. I can't tell you how many times I've seen people do something similar to this, and it just causes for a complete outage for a couple minutes. So use the policy installation target to make sure this particular policy is locked down to a particular firewall. So, alright, we have that in place now. So now let's do a policy, and now we're going to try to do an install and see what we get to. We may get an error message or we may not. What's it saying? It says show errors. And it says we have some conflicts going on. We got Rule 3 conflicts with Rule 4 for FTP services and all kinds of stuff. What that's basically stating, we need to clean up our rules and fix them because we had to remove a bunch of them earlier. Our stealth rule is going to say, like before, anybody toward the actual cluster object itself, we're going to drop them because we don't want anybody going directly toward our firewall. And it's going to be transparent to our users. And then we're going to set up a couple more options here where we're going to say for our management traffic, we're going to be able to connect over SSH, ICMP, or TCP from the Nugget trainer machine or the Nugget PCA toward our particular cluster. So we're going to add our cluster in here as well. So we'll right click, choose our Nugget cluster, hit OK there. That looks good. And let's do another verify. We're going to verify our policy. Bandwidth verification. It's okay. It likes it at this point. So what we can do, and I've told you this quite a bit through setting this type of firewall policy up in the first place, we could do things in the install on column. Now you can leave this to policy targets as long as you lock it in over here on the policy installation restriction screen under policy here. Now, or you can go back and lock it into the cluster object if that's something that you want to do to make sure you have, visual exactly what rule goes to what particular firewall. You can lock it in there. But for now, I'm going to leave mine on policy installation targets, and I locked it in under policy and then the policy installation target filtering. But anyway, so let's go ahead and get our policy deployed, and then we'll take a look at how to get everything set up here and make sure that our policy is working. We'll get our NATs back in place as well. So before we actually push the policy, let's go ahead and do that. We'll open up our internal subnet here. We'll choose NAT, tell it to an automatic hide NAT for us, hide behind the gateway, and let's hide behind the cluster object. That looks good. And now let's look at our other ones here. Now our Nugget PC is the 22 box, and we actually had a NAT on it here for, add a static NAT, put it on the cluster for 172.20.20.22. Looks good. We'll hit OK on that for now. And we had an actual object right here on our Nugget management server. So let's open that up. And we're going to NAT that particular management server out so we can get to actual firewalls in other locations that's going to be on the outside of our network. We got to have a public IP on it in order to set up SIC and push policy from our Nugget management server from the inside out across the internet. So we know this IP is going to be a 172.20.20.20. Looks good. And we're going to add that to our Nugget cluster. Alright. Same thing for our backup guy here. It's going to be a .21, so we're going to set that up with a static NAT over to 172.20.20.21. Looks good. Alright. That looks good as well. Let's put our Nugget cluster as our install on. Alright, so that should take care of all of our NATs. Let's just verify this one right here. Make sure we got 22. So we're using 20, 21, and 22. All as static NATs out to the internet. So let's try to do a policy install now and push this out and get our high availability mode cluster installed and configured. So this should just take a moment, and then once this installs we should be successful, and then we can verify the whole configuration of our cluster. So that looks perfectly in good shape at this point. So we hit OK or close right here, and we're going to collapse everything in this particular policy for now. And let's do some quick verification on what SmartView Monitor thinks about our particular cluster. So if we go to Window and we choose SmartView Monitor, and let's let it come up here and see if it's complaining about anything. Alright, so we have a problem and we have an attention. So if we refresh, it's saying that ClusterXL is not responding and installed on the cluster gateway. It should be installed and verified. And I want you to see that. That's one of the biggest cluster errors I've seen from time to time, is people forget to go into cpconfig and turn on the clustering mechanism when adding an existing gateway into a cluster. So you'll see that from time to time, and that's also going to cause a bit of an issue sometimes with your secondary member. But this guy has recovered right now, and because of the actual problem with this guy, we see that he is the primary active member. He is the owner of the virtual IPs, and he's serving those up to the internal as well as the external network, and the NATs that go to the external are going to be accessible through the secondary firewall. So what I'm going to do is I'm going to pause for a second. I'm going to go to this particular firewall. I'm going to get into cpconfig, enable the clustering mechanism, reboot this firewall, then we'll come back and everything should be in good shape. We're going to do some verification. We're going to test some failover, and that will wrap up our cluster new mode HA configuration. So let's pause for a couple minutes and we'll come back and check it all out. Alright everyone, we're back. Once we went into this particular firewall right here and we enabled the clustering mechanism under cpconfig and rebooted this box, it came in and it checked in just fine on the cluster. And what do we see here? Under cluster XL, high availability is the mode we're running, is the primary up, and it is currently the active member. So we're in good shape. And as we can see right here on the B member, we can see it's the standby for all the connections going through the virtual IPs on the inside and on the outside of our network that we configured in the topology screen of the cluster object. So we're in good shape. So now let's do a quick verification and see what the effects of having two gateways that are able to provide us complete redundancy in our network, and we'll test an actual failover configuration. And I want to show you one caveat that I tend to see in a lot of networks when someone goes to implement a cluster. Alright, so what we're going to do is we're going to actually bring up a command line menu right here, and from this command line menu we're just going to bring up a simple DOS box. Alright, and we're going to start up just a continuous ping, and as part of that continuous ping, what we're going to do, we can see that the ping is going to work pretty good for us. So we can stop that, and we're going to clear this screen and do a trace route -D 4.2.2.2, and we can see that this is our current path here. Our primary firewall is the 10.20.1.2, which is our 1A firewall. So we can see that at this point. Let's clear our screen, and let's go ahead and open up a PuTTY session to that particular firewall. So if we open up this particular firewall, the Nugget F1 firewall, so let's open that up, our A1. We're going to go ahead and log into it here. And what we're going to do is just do a quick verification. And this is one of the coolest things you can do. Once you get your high availability or load sharing firewall for that matter built out, test the actual failover. Go to each interface that you're clustering for and pull one of the interfaces on the actual firewall and watch how it fails over. It's beautiful. A lot of people, I like to see their faces turn white when I walk into the data center and just go over and unplug an interface, and nothing ever drops. And that's the cool part here. We're going to test, and we're also going to get into that caveat I was talking about. But anyway, let's go ahead and do an IP ADDR on this particular firewall. We can see that this is the particular interface for our inbound or our internal interface that's going to transfer to the outbound is on ETH2 for this firewall. And based on our trace results, we saw that it was .1, 2. Alright, so what we're going to do, we know this is ETH2. So we're going to start up a continuous ping. Let that run, and we're actually going to do an IF down on ETH2 to stop that interface and watch what happens. This should fail over in most cases, but in our case there's one more piece of information that I like to see. We're completely down at this point, and the reason why is we did not take into account the default gateway values on this particular host. So if we go in and we set the particular default gateway as this is going on, we can fix our problem. So if we go settings, network connections, let's open it up, and we have to remember that our virtual IP or our VIP for this network was the 1.1. 1.2 was the current firewall which was active, but there's a virtual IP that is going to act as the actual default gateway for everything in the 10.20 subnet, or 10.21 subnet, we should say. So let's put it to 10.20.1.1, and we'll start sending the packets toward our virtual IP. We'll click close on this. We'll go ahead and open up this DOS window, and what do we have? We're back up and going. Do not forget the whole option of the default gateway. I've seen more people cause themselves pain than I can count because of something simple as that. They forget that although they've defined a cluster, and whenever you run the trace route, the actual IP that you're going to see is the current member who is active and not the virtual IP. So that kind of confuses people sometimes. But let's look at one other option right here, and I want to show this to you as well. So let's go ahead and run a clear again on our DOS window, and we're going to do an ARP-A. And what we're going to see is, although it's ARPing for this particular IP address, the 5E86 for this node, it also has the 1.1 for this particular MAC address right here, which is the multicast MAC and for the virtual IP address. So that virtual IP address is going to sit behind this particular MAC address, and this MAC address is going to be transferred to whoever is the active member at the time. So some pretty cool features for sure. So that's the main thing I wanted you to see about the actual failover process with the new mode HA option in our checkpoint clustering option. So let's check that out. And the last thing that I want you to see is actually in the dashboard. So let's go ahead and open up dashboard here. And once we get that to pop up, you can see one more additional option for this particular one. And as we can see, it shows disconnected. And it's going to spin around, and it's going to give you some actual error messages because it's saying connection with that firewall is lost. But the point is, your company is still up because it's flowing through this one. This is the primary member, and it's active. And that's the beauty of having a cluster in your network, is that you don't have to worry about losing, a single interface or a hard drive or something along those lines that could completely cause your company an outage. So let's open up Smart Dashboard for a second. And let's look at an additional option for our new mode HA. Like I said, there's a ton of information on clustering, and we're going to get into all of it as part of all these cluster nuggets that we're going to cover. So it's going to take a second. It's going to load up our rules, and then I want to show you how to actually change the priority on who the actual active member is in your cluster. So we'll give it a second for the load up the rules, and then we'll check out the additional options that we have available. So now that we're in our cluster, we're going to see how we can increase and decrease the priority of which member is going to be the active member in our new mode HA cluster. So we'll open up our actual Nugget cluster object here, and if we select cluster members, we can see we can increase and decrease the priority of those particular members right here. Right now we have our secondary member as the primary. All we would have to do is choose decrease priority, and it would drop it to the secondary member. And we can do a quick verification of this just by running a trace route out to the internet, and we're going to see that our first packet here is going to be the 1020.1.3. So what we're going to do is to decrease the priority on that guy, make 1A the primary, hit OK, and then we're going to save this policy and push it out to our Nugget cluster. And once this gets pushed out, we're going to run another trace route to do a verification that we see 1.2 as our primary cluster member at that point. So we'll just take a second here, let this install, and then we'll jump into the verification on the command line. So it's going to take you a few minutes for this type of information to switch over, but it's pretty much seamless. If you need to do maintenance on a firewall in the middle of the day, you can make this type of change, push out the rule, get traffic flowing through the secondary member, and then go take that other firewall down if you need to in order to replace a network card or hard drive or power supply or whatever you may need to do. You have the ability to do that. So let's go ahead and run our verification here, and we're going to see our primary member has migrated over to the 1.2. So if we needed to do work on our secondary member 1.3, we could at this point. That's the main thing I wanted you to see from the GUI side of how we could do a quick migration of the primary and secondary member. How we could increase or decrease the priority between the two members. So let's get out of here for now. And we're going to jump into the command line, and we're going to do a few verification commands on how do we find out if our cluster is running properly. Now these are some important commands that you're going to need to know, and it's going to be something you're definitely going to use in your daily basis for your own clustering and troubleshooting, as well as your CCSE objectives. So let's go ahead and open this up. We're going to connect to our actual secondary firewall, which is 1020.1.3, and once this pops up here, we should get a prompt to log in, and we're going to log in. Now there's a few basic commands we need to understand. The first one's going to be a ckpt prob. It's going to give us a few options. We have state, we have -AIF, and we have a few other options here that we're going to use throughout our discussion on clustering in this series. But for now, I want to show you a few of the more important ones that you need to know when verifying your cluster. The first one is ckpt prob, state, or stat. Either one works. So you could do that, or you could do stat, and you get the same value. And what you're going to see who is the current active member. We can see that the local member is the standby because we're on our second firewall and we increased our priority earlier. We can see that the unique address we're going to see is the sync interface between these two firewalls. We're going to see which firewall we're currently on, which is the local, and we can see that it's standby. And we can see the cluster mode that we're running in is the new mode high availability primary up. So we're in good shape. So the next one we want to look at is the ckpt prob -a space -if command. Now this is something that you're going to need to understand. You're going to see ETH0 is being up, ETH1 for sync, and ETH2 is going to be our internal link. We're also going to see the virtual cluster interfaces right here. So if there's ever a question, what are your cluster interfaces and you can't get to Smart Dashboard, you can log in via PuTTY to the command line of your firewall, run this command, and you would be able to tell right here. And you're going to be able to see for each set of interfaces that you have set up in a cluster, maybe it's 3, 12, I've even seen some firewalls with at least 24 interfaces installed in them. And Checkpoint's Cluster XL can handle this type of throughput with no problem. And the point that we see is that it's going to give us a verification. We see that these are up, and now we're going to see the sync is always going to be shown as a secured interface. And the actual cluster interface, they're going to say non-secured. The reason why you see that is typically because the secured interface for sync is pretty much controlled. We know that all that's really going to flow over that is CCP packets and UDP 8116 packets for the cluster control protocol. And that's pretty much, it's going to be a controlled environment for updating what's going on in the connections table and the VPN connections and everything that's flowing from one member into the secondary member in the cluster, just to make sure if we did have a failure, the secondary member could take over and you wouldn't lose a beat whenever you're passing traffic through your firewall. So that's the next command we need to see. And the last command that we need to be familiar with is the actual ckpt prob -i space list. And actually, I'm going to throw one more command in the mix. Before we jump into the ckpt prob -i, I want to show you one more command that I tend to see quite a bit, and it's quite useful for resolving problems. So as we can see, when we run this command, we see multicast. Now, in a new mode HA cluster, from time to time, some switches and routers don't handle this type of cluster update traffic between the two cluster members in a good fashion, and sometimes you get some interface flapping going on where you will see in your tracker your primary or secondary member will be up, down, up, down, up, down, up, down, and you'll get cluster control actual log entry saying that receive up, transmit down, receive up, transmit down. And it's going to get some interface flapping. Now, how do you solve this? In most cases, you can just run a simple command of changing it from multicast to broadcast for the cluster control protocol update process between your nodes. And there's a simple command for doing that. It's going to be cpe ha conf space set _ ccp to broadcast. And now, when we run our -AIF, we can see everything jump from multicast to broadcast. So from time to time, you may need to do that to resolve a problem. But in some situations, multicast is going to work for you, and you're not going to have to make that kind of change. But I just want to show you that one quick little troubleshooting step if you need it. So we'll switch it back to the multicast. We'll do our verification, and we're back on multicast for our cluster control protocol. So let's go ahead and clear this out. And the last one we're going to get into is the cpha prob-i space list. Alright, so what do we see here? Now, whenever we set up our actual cluster, these are all critical devices that must be up and running. It's going to do an interface active check. It's going to say, I have these interfaces defined in my cluster object. Are they up? Okay, great. It's going to look for the high availability status. Is it initialized and turned on via the cpconfig menu? It is? Great. So we're in good shape. It's in the OK status. Now, registered devices, it's going to look at the sync. Is the sync working as it should be between the members? Status is OK. Filter, do we have a firewall policy installed? It's OK. And then we have our checkpoint HA daemon. Is it OK? We're good. And the last thing it's going to check out by default is going to be our firewall daemon, making sure that that's up and running in order to pass traffic and to filter traffic coming through one of our cluster members. And in a proper running setup, as we would see here, everything is going to be in an OK status, and that's the main thing we need to understand for how to verify what's going on with our cluster via the command line. So once you master all the GUI commands that I've showed you and all the command line options that we just went through, you're going to be in good shape to run and control and to be able to deploy a checkpoint new mode HA cluster solution. In this nugget, we covered firewall clustering part 1. We looked at the actual migration from a single firewall into a clustered firewall configuration. We also looked at new mode HA cluster objects and configurations and everything that we needed to do to bring it from a single firewall into a clustered firewall configuration. And then we performed the verification of that cluster. We tested the failover. We looked at everything in the GUI windows as well as on the command line to make sure this cluster is running as we would expect it to be, and that it's going to provide complete redundancy for our network should we lose a cluster firewall due to some kind of hardware or maybe power failure. I hope this has been informative for you, and I'd like to thank you for viewing.